The physics of indoor cycling. In the 1980s, a cyclist named Jonathan Goldberg found himself riding and training indoors. He had an idea to develop a stationary bike that would feel similar to riding on the road. After numerous versions and adjustments to the prototype, he had finally created a fixed-gear ratio stationary bike with a flywheel and an adjustable tension knob that made riding indoors feel similar to riding on the road. He opened up an old garage and created the first indoor cycling studio in California. By 1991, Johnny teamed up with a good friend to refine the design and create the first ever spinner bike, which is now used in cycling studios today, such as SoulCycle.
The SoulCycle was founded by two strangers who met at a lunch.
First location on Craigslist.
These two women were interested in finding a full-body workout to engage the mind, body, and soul. Spinning bikes are designed to hold a person's weight and rapid cycling motion due to the combination of a sturdy build and special wheel design. The spinning bike's only wheel is connected to a weighted flywheel that has pedals attached to it. The tension on the wheel can be adjusted by a special knob located either in the front of the seat on the frame or in the middle of the handlebar. The pedals have straps to keep the cyclist's feet in place during the high speeds. There is no rear wheel as the spinning bike is designed to be stationary. The body construction is made of extra strong steel in order to handle the stress of continuous body position changes and speed changes. For this project, I wanted to calculate the linear acceleration of a stationary bike. I looked at a diagram that showed the different forces acting on the bike. To find the linear acceleration of a bike, use the equation where A equals the radius of the tires times the force applied vertically at a right angle to the pedal arm, times the length of the pedal arm, times the radius of a sprocket, which is then divided by twice the inertia of the back tire times the mass of the bike and the rider times the radius of both the tires. During a spinning workout, the cadence and resistance changes quite frequently. The cadence is equal to the number of rotations of the flywheel per minute. The resistance can be changed by the gear ratio knob, which I mentioned before. The gear ratio is the ratio of the number of teeth on the chaining of the cranket to the teeth on the rear sprocket. By looking at the equation provided earlier, I found out that the smaller the gear ratio, the larger the acceleration. This will provide the cyclist with a lighter workout. To maintain a constant velocity, the cyclist will need a larger gear ratio. If you have a larger gear ratio, the rider will be able to ride a series of rolling hills. For example, if you had a gear ratio of 4 and a wheel diameter of 27 inches, you would multiply the two and you'd get an equivalent wheel size to be 108 inches. That means that using a gear ratio of 4 on a bike with a wheel diameter of 27 inches is the same as riding a direct drive wheel with a diameter of 108 inches. Gear ratio and cadence are important factors in spinning in order to achieve the most out of the workout.